You know, when you think about it, it's hard to find a better formal model of a political process than chess. The name of the game of chess is to try to use your pieces to attack and ultimately capture your enemy's king. Each side has a king. It's the piece with the cross on top of it. The king isn't the most powerful piece that any given side has, but it is the most important because if somebody manages to attack the square that the king finds himself on, and the king can either get rid of the attacker or block the attack or get out of the way of the attack. In other words, if the king is truly trapped by some attack made by the opposing side, then he is defeated and the game ends in what is called checkmate. Of course, getting the checkmate is a multi-move affair. We don't play chess quickly. There are many moves involved. Our goal is to get our pieces developed by getting them all over this 64 square battlefield that really is what a chessboard is meant to represent. And so over the course of the game, each of the respective pieces is deployed somewhere on the battlefield, and threats are made and parried until pieces are captured one by one, until next thing you know, the game has been simplified, and ultimately two kings and whatever's left of their army find themselves on the battlefield. Chess is definitely one of the more fun fables that somebody can tell, so let's get to it. Once upon a time, there were two kings. You're a king, I'm a king. We are two kings. You have the white pieces, and I have the black pieces. By convention, the white pieces move first. And so you decide at the beginning of the battle to send one of your foot soldiers to the middle of the board by playing e4. I decide to respond in kind, not allowing you to take too much control of the strategically important center of the board by playing e5. You use one of your snipers, a bishop, to come out and attack one of the weaker spots in black's defenses by playing bishop to c4. I decide to use my turn by taking one of my knights and letting them hop out toward the middle of the board to protect the foot soldier that I've deployed by playing knight to c6. You sense some weakness and allow your most powerful piece on the entire board, your queen, to hop out to the flank for an attack by playing queen to h5. And I decide that I need to attack your queen to get rid of her, to make her go away from my defenses. And so I send my other knight out to the middle of the board by playing knight to f6. Notice, however, that now your queen has the ability to kill me, the black king. Why? Because your sniper, the light-squared bishop, on c4, and your most powerful piece, Her Majesty herself, on h5, have the ability to work together to attack the single weakest spot in my defenses, the f7 square. Your queen attacks my foot soldier, and next thing you know, my powerful queen is unattackable because she is defended by the sniper who is playing backup. Your king cannot escape because anywhere that he goes, the queen will still be attacking him, and no other piece can get rid of the queen, and therefore her attack is truly fatal. The game is over, and we find ourselves at checkmate. This is one of the more famous mating patterns that one learns early on in one's chess training. It's referred to as the scholar's mate. It's one of the quickest checkmates that happens. It takes only 4 moves of back and forth between the two of us. But this, of course, raises the question. If you just managed to dupe me into something called the scholar's mate, then just what kind of scholar is it that's teaching you something in this class? Hey everybody, welcome to PS231. So just real fast, I love playing chess. Maybe some of you love playing chess, and once we're done being professor and student, maybe we can, I don't know, get to be friends on chess.com or Chess or something like that. It would be nice to play some chess with you. I'm not very good, but I usually play interesting moves. I prefer interesting moves to good moves. That's what I tell myself anyway. Now, I didn't just mention chess for reasons of vanity. I mean, I do everything here for reasons of vanity, but the reason to bring up chess is that it helps to illustrate a really important point about a problem with our theory up to this point. I think you would agree with me that chess is strategic, right? Typically, when people think about strategy, one cliche thing that comes up is that the idea of two people playing chess. Who is more strategic seeming than a chess grandmaster? Grandmasters seem so strategic. They're like enlightened Buddhas of strategy, right? I've had a chess set on the set for a while because I think that it helps to convey the idea of strategy, and I've had that one hand making a chess move in the clappy intro because I think that helps to convey the notion of strategy in our class called strategic models. Chess is actually an especially appropriate time to think about strategy because it's about two generals, more or less, right? The two kings might as well be two generals on a battlefield. And it turns out that the word strategy, the etymology of strategy, is itself linked back to a Greek word for general, as in something military. In other words, I feel incredibly comfortable saying that if something applies to chess, it is probably pretty strategic. And if there's a feature of chess that's like a really important feature of chess that our models can't tap into, then my sense is that our models are somewhat impoverished. So I would like you to consider some things that happened during the cold intro. One player moved first, and then another player responded, and then the first player responded, and then the second player responded. White moved, then black moved, then white moved, then black moved. Right, so what happens? There's a sequence of moves, right? There's a sequence of moves. White plays e4, and then black observes that and responds with e5. Maybe they would have played a different move if white had played a different move. And then white observes what black did and knows what they did and decides to play bishop to c4. And then black observes everything that's happened up to this point and then makes the decision to play knight to c6. And then white observes everything that has happened up to this point and decides to play the aggressive queen to h5. And then black gets flustered and decides to respond to that queen move by playing knight to f6. And then white says, well, the best thing that I can do right now is take this checkmate in one. And so they play queen takes on f7 checkmate. First, and then, with choices and observations, and choices and observations, and choices and observations playing out over time. Time. Strategic time. It might not be an hour in between moves on the battlefield. It might not be 5 hours or a day or a week. We don't know what the gap of time is in between the moves on a chessboard, but we do know that one player moves first and then at some other time later, whenever it happens to be, at some qualitatively later moment in time, the other player gets to make a move. There's a sequence of moves that plays out over time and where certain players get to observe what has been done. And we haven't talked about any of that. And that's part of the soul of chess, which makes me think that I've been doing a pretty bad job. And you're like, you needed chess for that? Up to this point, we've been thinking about games where the players moved simultaneously. I go straight and swerve, and you go straight or swerve at basically the same time. It's not the exact same time, but it might as well be, because there's no way for us, the analyst, the god of the fable world, to say, well, and one of the drivers gets a split-second instantaneous prior observation. We just said that they're moving as if simultaneous. When we're driving on the road, we're driving as if simultaneous. There isn't any opportunity for us to think about different contingencies because we're living in this one synchronous contingency that we find ourselves in a strategic form game, the games we've been studying for the last 3 weeks. So we need to add something to our apparatus. We need to come up with a richer theory that allows for the potential of dynamic influences. How does a rational player learn from what they saw in the past, make decisions about what they're going to see in the future, and then use that to influence their strategic problem today? How do they make choices today based on what they've seen in the past and what they think is going to happen in the future? Time, past, present, future. So that's what we're going to be talking about over the next few weeks. Extensive form games and the way that we study them in order to enrich our notion of Nash equilibrium. So we'll be enriching our theories by incorporating a time structure and then exploiting that enrichment to enrich our notion of Nash equilibrium into something that allows for credibility. Believe it or not, this is going to be a somewhat intuitive lecture for you. You're going to be way better at thinking about strategy over time than you were in simultaneous move games. Think about all the hypotheticals that we had to go through in finding Nash equilibrium in strategic form games. Right? It might be consider that we're in one row held fixed, or consider that we're in one column held fixed, or maybe we're thinking things through about best response. And don't get me wrong, there's going to be plenty of contingencies we have to think our way through in extensive form games, but you're going to be able to see them. You're going to be able to play with the objects a little bit more easily. There's a little bit more intuition involved. Because this represents such a qualitative break in our class, I think I don't need to frame things too much more. You know that this is important because you just let me fall for Scholar's Mate. We don't have to talk about this anymore. I don't understand why we're not already getting to it. I don't know why in the past I haven't already said get yourself some liquids. I don't know why in the past I haven't already said get yourself some soft pants. I don't know why in the past I haven't already said get yourself some aromatherapy and some binaural beats and get yourself a dog to squeeze. I don't know why I haven't said any in the past, but I want to have a past to be able to talk about, so we better get to it in the future. In the A block, I want to show you the simplest entry point for games like this by talking about candidate entry. We will study the simplest possible extensive form game, and we will talk about how what we've seen in the past about strategic form games relates to what we see. We'll see that we're actually taking a strategic form game and adding something to it, which means that we can study it the old way, but then if we see it from the new angle, we'll be able to study it a new way too. In the B block, I want to talk about richer action spaces by introducing one of the most important games in all of game theory, the Ultimatum game. We'll see that the Ultimatum game is our way to think about bargaining in a dynamic situation. We've thought about bargaining. We've drawn lots of utility imputation spaces. We've thought about disagreement points. We've found Pareto frontiers. But we haven't thought about what is the process by which bargaining decisions are made. The Ultimatum game is the simplest such protocol that takes us from a bargaining problem to a bargaining outcome. I'll show you that it is indeed a bargaining problem and demonstrate that there's a couple of extra wrinkles that happen for purely mathematical reasons, but that introduce an awful lot of nuance, some interesting substantive and strategic nuance to the problem of setting a strategic slider, figuring out how much of something you'd like to keep for yourself. If all goes well, I'll also demonstrate that the Ultimatum game is related to a well-known legislative model so that you can see that the model is immediately applicable to political processes. On the subject of politics in the C block, we'll talk about the rule of law model. So it's a model that'll come up pretty often. We use it to introduce the notion of information sets, but the story is itself substantively interesting. We'll study what happens when a ruler has to decide whether or not to repress the people under the expectation that in the future, those people, if repressed, might decide to coordinate on throwing the bastard out. Past, present, future, past, present, future, past, present, future. In the past, what have I learned? In the future, what do I expect? Today, what should I do? We're going to start talking about that, which is good news because we're still just on the beginning of our journey. We have so much to look forward to, even though we have so much to be proud of behind us. So I can't wait to show you some of this stuff because I think that this should get pretty fun pretty fast. So let's get started. Movie 51 is off to an amazing start. That's all downhill from here, though. And to be honest, I didn't have a very high bar, did I? Regardless, here in the A block, I want to talk about some simple examples. Boy, I held that pretty good. Did you see that? That was pretty good form, too. I think I'm just on my A game today. Just wait till all the lights just burn out because their batteries went down. So to get ourselves started, I think we should just write down the very simplest game that involves time that we could. So let's introduce an incredibly simple model of candidate entry. So here's the idea. Once upon a time, there was somebody that was considering running for office. We'll call them the challenger. So once upon a time, there was a political challenger, and the political challenger was thinking through whether or not they should run for office. Now, the challenger knew that in their district, there lived an incumbent who had been in the position for some time. And the challenger was thinking through, well, if I run for office, maybe the incumbent will decide that it's time to retire. Otherwise, if the incumbent is allowed to run unopposed, as so many incumbents do, or essentially do, then they'll just stay in office. So if you're a political challenger that's thinking about running for office, but is worried about the incumbency effect that benefits your potential opponent should you decide to run for office, then you have to think through what you can expect that opponent to do if you actually issue a threat. And so there's a time element involved. The challenger makes a decision about whether or not to run, and then the incumbent gets to observe that and decide whether or not to retire. So how do we encode that? So the basic idea here is that we're going to develop what's called a game tree. A game tree is just a visual depiction of an extensive form game. Most extensive form games you can draw with one kind of game tree or another. There are exceptions, and they're pains in the We'll stick to pretty simple, pretty visual ones if it's okay with you. And so a game tree is comprised of several components. The most prominent of these are nodes. Nodes are just circles. They're just dots. The fancy word is nodes. We're going to draw a graph that involves dots that are connected with lines. Those are called edges. And we'll see that the dots and the edges convey particular meaning about particular aspects of our political problem. The most prominent kind of nodes in a decision tree are the decision nodes. These are nodes at which one and only one player makes some strategic choice. So at any given node, a given player has some set of actions available to them. The other important kind of nodes for our introductory example are the terminal nodes. Terminal nodes represent the outcomes. They represent the ending of our dynamic stories. Early on, it's okay if we say to ourselves, and there are preferences over the terminal nodes, but you'll see in a couple of weeks that that is actually a somewhat dangerous little mini trap. But most of the time, we won't hurt ourselves too badly if we say that the players have preferences over the terminal nodes, and thus the endings of the story. I'm being a little bit cryptic, so let me show you what I mean. The first thing that I want you to do is imagine that running from left to right, strategic time goes this direction, okay? So these are earlier events and these are later events. That's what time does. You'll remember in our Once Upon a Time, the challenger decides to run for office first. They don't observe anything in the past. Their move might as well be at the beginning of time. So let's just put a decision node right here. And this represents the challenger's initial decision of whether or not to run for office. So this decision node, notice that it's labeled with a C. That means challenger. So instead of a matrix sort of thing, we'll see that matrices are going to be haunting us forever, but we're going to start just from a node that is controlled by one of the players. Okay? Now, out of this node will come a number of edges where every edge represents a strategy available to that player at that node. So I told you that in this story, at the beginning of time, the challenger could decide to run for office or not run for office. So we'll say that if the challenger doesn't run for office, then they ride down this edge, which I will label don't run. So they can either not run or they can run. Okay, so they can not run or they can run. If they don't run for office, we'll say that that's the end of the game. We'll say that that's the ending because they didn't do anything. This is going to be something like the status quo. If the challenger decides not to get the game going, then we just kind of wind up where we were, and there's no future strategic interaction. If I don't run for office, then I can't have a campaign against you, right? Now, if the challenger does decide to run, though, then the incumbent gets to make a choice, right? That's the whole point, is then the incumbent gets to make a choice. And so right here, I'll put another decision node labeled I for the incumbent. And we'll say that the incumbent has one of two choices. The incumbent can either retire, and then we wind up in an outcome where the challenger has the office and the incumbent is retired somewhere, or the incumbent can decide to campaign. They can say, you know what? You think you're coming after me? You don't even know who I am. Who are you coming after? I'm Mo Green. I made my bones when you were just a punk. So we have three different endings to the story, right? We have the one where the challenger decided not to run, and so we just wind up at the status quo. We have another one where the challenger decides to run, and then the incumbent decides to retire, and the challenger gets the job. Or we have a final ending where the challenger decides to run for office, and the incumbent says, well, now you just pissed me off. Let's have a fight. Let's campaign. So this tree represents the strategic interaction between these two players. Notice that there's a difference now between the players. The challenger moves first. They don't see anything behind them, but they do get to act with expectations of what will happen in the future. The incumbent, on the other hand, doesn't move first. They observe what happened in the past, namely the challenger's choice, and then they get to decide what to do based on what they saw in the past. So they have different things available to them. They have different strategic possibilities, not because they have different actions available to them, although that's part of it, but also because they have different abilities to observe and expect over time. I need to put some utilities on here, right? So we've got a game, we've got players, We've got things they can do, but we don't have utilities yet. We need to add some preferences. And so, like I said, for now, we can just think about utilities as something that happens on these terminal nodes, these three endings of the stories. So we'll say that if the challenger doesn't run for office, if the challenger doesn't run, then we'll normalize their payoff to 0. Their status quo payoff is 0. And we'll say that the incumbent gets to enjoy the benefit of office, which is worth 1 happiness point to them. Let's say that if the challenger runs and the incumbent retires, we'll say that's 1 happiness point for the challenger, who is now in office, and we'll put 0 happiness points there for the incumbent, who doesn't mind retiring because they're at the end of the career or whatever, something like that. Finally, we'll say that if the challenger runs and the incumbent campaigns, minus 1 happiness points for the challenger, who doesn't like campaigning against somebody with incumbency effects, and minus 1 for the now complacent incumbent. So now we have an extensive form game here. This is an extensive form game. This is a game where we have players, the challenger, and the incumbent. Each has a set of available actions. Don't run, run, retire, campaign. Each has available actions, and each has preferences over the combinations of those choices, right? So there's actually 4 combinations of choices, just like there were before. We could take this tree and put it into a matrix. So let's just go back to our comfortable world of matrices and take what we have in this tree and put it into a matrix. We'll say that the challenger is the row player, and we'll say that the incumbent is the column player, which means that the row player, the challenger, can either not run or run. And the incumbent can either retire or campaign. Notice now that if the challenger decides to not run, then no matter what, we wind up at the same outcome. No matter what the incumbent does, we wind up at the status quo, which is 0 for the challenger and 1 for the incumbent. However, down in the world where the challenger decides to run, then we get some intrigue. So if the challenger decides to run for office and the incumbent retires, then that's 1 happiness point for the challenger, who's in office now, and 0 for the incumbent, who's enjoying taking over the board at their new retirement community. Finally, if the challenger runs and the incumbent campaigns, we wind up at minus 1 happiness points apiece. This is now the simultaneous version. This is now the simultaneous version of that game that we just drew out as a tree. This is what happens if we pretended that time wasn't a factor. And you'll notice that if we pretend that time isn't a factor, we wind up with a game with 2 pure strategy Nash equilibria. There's 1 pure strategy Nash equilibrium where the challenger decides to run and the incumbent decides to retire. Right? The challenger is happy because they get the 1 happiness point of being in office, and the incumbent is happy because if they deviated, they would have to be in a campaign that they're too complacent to go through with. There exists another pure strategy Nash equilibrium, however. It's the one where the challenger doesn't run and the incumbent campaigns, which is a pure hypothetical. What do I mean it's a pure hypothetical? Well, let's go back to the tree. Notice that I identified 4 pure strategy profiles, right? There's the one where there's no running and retiring, the one where there's no running and campaigning, the one where there's running and then retiring, and the one where there's running and then campaigning. However, for all of the ones where the challenger doesn't run, what happens over here is a pure hypothetical. It's a hypothetical. It's what happens down the tree in the world that we don't get to observe because there wasn't any campaign. Oh boy, look at that. We never had a campaign, so we don't get to observe what would have happened. But we'll see next week that what happens in the hypothetical world has big effects on what happens in the world that we observe. So I identified 2 pure strategy Nash equilibria. There's the one where there's no running and a campaign, which is a pure hypothetical. And there's another one where there's running and then retirement. And for the next week, I'd like you to ponder on which of those seems to be reasonable given the time structure and which of them doesn't. In other words, can we refine what we learned in the simultaneous world with this time structure to say some of the original Nash equilibrium predictions seem reasonable and others don't? Reasonable in the sense that time has been respected. Strategic time has been respected. That's what we're talking about here. Of course, there's no rule that says that you can just have one choice and then another choice. Maybe there's multiple choices. So let me just show you a simple model of a model that we'll study once we get to incomplete information that's relevant in international relations. It'll be a simple model of audience costs. So the idea with audience costs is that domestic audiences don't like it when their leader does the following. They don't like it when their leader issues threats. They just walk around acting like a bully. They're like, hey, other country, give me some stuff. And then that other country says, you want to fight? And then the person that made the threat, the bully, they're like, oh yeah, wait, I didn't really mean it. So the idea is that those threats that then you have to go back on, where you come forward, then somebody calls you out, and then you hide. If it's like Drake and Macklemore, then the domestic audience, the domestic population is going to get really mad because the leader just wasted a lot of strategic capital, maybe wasted a lot of human capital, just put an awful lot into a fool's errand of making a threat that then they wound up backing down from, so now they look like an idiot. So how do we encode that? So once again, let's have strategic time going from left to right. And we'll say that there's two countries, country A and country B. I'm a country, you're a country, we are two countries. I'll be country A and you'll be country B. So at the beginning of time, country A can make a move. They can either not make a threat, they can do nothing, they can do absolutely nothing. They can just sit on their hands, or they can issue a threat. Right? They can issue a threat. They can rock up to state B and be like, hey, I'm going to need some of this territory. Or, hey, your ruler kind of sucks. Could you get a different one? Now, we'll say that if country A doesn't do anything, that'll just be a status quo, nothing happened. All right? And then we'll say that country B, if threatened, has one of two choices. They can either acquiesce to the threat. They can acquiesce to the threat. They can say, oh my God, you're right. Oh, no. Please don't hit me. Please don't hit me. Country A, please don't hit me. And we'll call that a terminal outcome called country B acquiesced. Or they can say, bring it. They can stand firm. They can say, you know what? You think you can make threats? Why don't you just bring your army out after school and we'll see who's stronger. So country A can do nothing or they can threaten. And then country B can either acquiesce or they can stand firm. And then the idea is that country A then has to live up to their challenge. If somebody stands firm, then you have to actually carry through. You have to actually go through with what you said you were going to do. So we'll say that country A then has a final choice. They can either fight, they can actually fight. They can say, you know what? I promised I would fight and here I am. It is time to fight. Or they can back down. They can back down. They can back down. So now we've got a few more different endings, but the story isn't that much more complicated, right? So we'll say that if country A doesn't do anything, if we just wind up at the original status quo, we'll say 0 happiness points for country A and 1 happiness point for country B. We'll say that if there's acquiescence, then those are flipped. So if country A issues the threat and country B acquiesces, then we'll say 1 happiness point for country A. They just took the thing that like we're fighting over, and 0 happiness points for country B. They just got stuff taken from them. Now they acquiesce. They look like an idiot. We'll say that if country A issues the threat, country B stands firm, and then country A fights, we'll just say that there's some war payoffs there. So I'll just put W sub A and W sub B, where those are like, what is the war payoff in happiness numbers? You could do it like P minus C and 1 minus P minus C if you wanted to, like Bargainement of war. But it's just easier if we just say, what's the war payoff? It might be an expectation. It might be not an expectation. We'll just say you get W. You get W happiness points if you win, if you fight. Finally, we'll say that if country A makes a threat, country B stands firm, and then country A backs down. We'll say that gets country B 1 plus alpha, where like alpha is your new toughness. Like somebody made a threat, you stood firm, and then they backed down. Maybe you get a reputational benefit, which I'll just call alpha. So you get the one you had before plus this alpha. And we'll say that country A has to have minus A. That's the audience cost. That's what happens if you make a threat that then gets called, that somebody calls your bluff and then you back down. That's minus A happiness points because your domestic audience is mad at you. This is a very simple, straightforward model of audience costs. It's not very interesting as it sits, but it gets very interesting once one country gets to know their audience cost and another country doesn't. We'll talk about that one in a few weeks once we've introduced time and information and how they intersect with one another. But even in the absence of this model being all the way satisfying, it's kind of interesting just to think about how would I define an audience cost? How would I encode the thing that I tried to tell you with the once upon a time? Once upon a time, there was an overly cavalier leader who issued a threat that got called out and then they had to back down and the people were really mad at them. This is that story. This is that story. This is that story. It's not all the way satisfying, but if you ask me what an audience cost is, I couldn't really tell you without this. This is how I see them. This is how you, right? I mean, they exist verbally, they exist, and you can see them out in the real world. We know that there are countries that have experienced decisive audience costs, but like, this might as well be the definition if you ask me. So this tree is a nice way for us to micro-found to operationalize a really important concept that lives out there in the wild called audience costs. I got one more to show you. There's no rule that says I have to stop at 3. There's no rule that says I have to stop, actually. So I'll show you one that can kind of go on forever. That's a very important game within experimental political science, where we're testing to see whether or not flesh and blood human beings live up to the rationality postulates that we've leaned on so heavily. So let me show you one really final cool game that's called Centipede. There's a way to try to tell a story around it, but this is not really great. I'm not going to bother trying to tell the story that one uses with Centipede. I'm just going to draw a game, and I'll say that this has something to do with like whether or not two parties can cooperate with one another when there's an incentive for sort of like collective action problem-y sort of reasons to be greedy. But the longer that we cooperate, the better that things get. And thus, the stronger that greed incentive becomes. Okay, that's the idea. We'd like to keep cooperating, but if I pass the ball back to you, maybe you'll take the ball and go home. I thought we were having fun. So we'll say there's 2 players, player 1 and player 2. And we'll have strategic time go from left to right. And at the beginning of time, player 1 has a move. They can either just take the money. They can just take what's out there, and that'll be a terminal node. Or they can pass it. They can pass it to player 2. And this is what's going to happen, is then player 2 can either take the money and end the game, or they can pass it. And then player 1 has a new chance. They can either take the money, or they can pass it. And I'll put some ... in there just to say this could keep going. And then let's just say that there is an end of time on this one. So at the end of time, on the very last decision, player 1 can either take or pass, and then player 2 can either take or pass, and that's the end. Now, what makes this game tragic is the following. We'll say that at the beginning of time, if player 1 takes on the first chance that they get, then they get 1 happiness point and player 2 gets 0. Basically, they just keep whatever the tiny thing that got started was. If player 1 passes and then player 2 takes, 0 happiness points for player 1 who doesn't have the ball anymore, and 2 happiness points for player 2. The idea is that it's going to grow as we go. It's going to keep growing as we go. For example, the next turn, if player 1 takes, we'll say 3 happiness points for player 1 and 1 for player 2. Then we'll say that if player 2 takes on the second turn, 1 happiness point for player 1 and 4 happiness points for player 2, and so on. The idea is that as we move from left to right, both players' happiness points are going to get bigger and bigger, but the person that has an incentive to take is they're the one that has control. The one that has an incentive to take does better if they take. Until we wind up at some situation where we have happiness point numbers that are very big. Many more resources are out there. Many more pennies are in our mugs. We might not like the distribution of them because we're thinking to ourselves, well, I could have taken in the previous round and done better. But that's the idea. I can be greedy or I can pass it. I can be greedy or I can pass it. I can be greedy or I can pass it. I can invest in our future. I can invest in our future. I can invest in our future. You can do the same. You can do the same. You can do the same. We keep growing. We keep growing. We keep growing. And then you cheated, you asshole. Then you took all the money. Now, in theory, that can go on forever. There's no reason that even though you and I aren't going to be here forever, there's no reason the player in 1 and player 2 can't. And so you could imagine these sums of money that we're investing over time could get very big very quickly. And thus it would be genuinely tragic if we weren't able to cooperate for a while, right? If we don't manage to cooperate for a while, then we're stuck with paltry numbers over here. We need to invest together, but at any point in time, whoever is moving has the initiative to take a whole lot. They have a chance to be cheaters. Centipede. We'll talk about the result that you get out of Centipede next week, and we'll see that there's some perverse relationships between what actual people do and how people should how people should play Centipede based on the rationality predictions. And we'll see that there's an interesting tension there that's worth exploring. So we've got 3 different models where essentially one player can opt out of the game at any point in time. So in candidate entry, the challenger could have opted out and we go to a status quo. In audience cost, country A could have opted out and we found ourselves at the status quo. In Centipede, player 1 could have just taken on the first day and we just wind up at some crappy status quo. So in all of these, strategic time has the idea where you can basically decide to keep the game going or you can say we're done. Now that's not the only way to use time, but that's a very interesting introductory way to get involved. What happens if you can either do nothing or choose to get in? What kind of strategic tensions do you see down the line compared to the sure thing of doing nothing when you don't quite know what's going to come after you based on the strategic choices of other players? That's as strategic as it gets, right? You say that, but actually we'll see a few more wrinkles over in the B block when we talk about the Ultimatum game. Very much looking forward to that. See you in a bit. So here in the B block, I want to talk about the Ultimatum game. That sounds tough, right? Whoa. This got nasty in a hurry. So the Ultimatum game is a way for us to encode the tension of bargaining, where one player does well when the other does badly. There's a zero-summy sort of quality. However, the two players have an incentive to make a deal. Okay, so the Ultimatum game is the first dynamic way for us to think about how to navigate the tension of we both want to make a deal, but we don't agree about which deals are good. In order to encode this, I'm just going to do this abstractly to begin. So we'll say that there's two players, player 1 and player 2. And this time we'll have strategic time go from top to bottom. And what I'm going to say is that at the beginning of time, player 1 can make an offer to player 2. You can imagine bargaining happening like, I'll offer you $10 for this. No, I'll need 20. Oh, I'll offer you 15. How about 18? How about 16? And so on. We're not going to have the iterations, although models of that exist. Instead, we're going to say what happens in the simplest version where I make you one and only one offer and you can take it or leave it. So we'll be studying what's called take it or leave it bargaining. The Ultimatum game is a take it or leave it bargaining game. The thing that makes this wrinkled and nuanced is the fact that when I make an offer to you, when I set a slider, if I set a tax rate, if my offer to you is what tax rate you're going to have to pay, or what salary I could offer you, if my offer to you is something quantitative like that, then I can choose from a richer strategy space. It's not just like one of these discrete go up or go down. It's not like run or don't run. Now it's going to be something a little bit more subtle. It doesn't create too many more tensions, although the analysis is a little bit trickier. But I think that the stories are just as easy to tell this way. We'll see the analysis is a little bit more wrinkled. So we'll motivate this by saying that there's some issue, there's some goodie that the players are figuring out how to divide. We'll call it $1. Okay, so we're going to call this divide the dollar. We'll say that at the beginning of time, player 1 chooses some X that lives between 0 and 1. That's the proportion of the dollar that they keep for themselves. And then 1 minus X of the dollar goes to player 2. So what I'm going to say is at the beginning of time, player 1 makes a move. So here's player 1's decision node. And the idea here is that player 1 is going to be able to choose between choosing some X that's very low so that they don't keep much of the dollar and player 2 gets much of it. Or they could set X equals very high so that they get to keep most of the dollar and player 2 doesn't get much. Or they could choose any X that lives in between. So we'll say that player 1 can actually choose some X out of this entire Assassin's Creed hoodie. They can let X equals 3/4 or X equals 1/4. They can choose any X that lives in between. Right? They basically have this entire slider to work with. Now I look like I'm conducting. They have everything here to play with, okay? There's an uncountably infinite number of things that you could choose. You could choose, there's so many X's that you could choose. Any X that lives between 0 and 1. So that's the offer that player 1 makes. Player 1 says, you know what? There's $1 here and I'm going to keep X of it and you can keep 1 minus X of it. We've all been there before. Notice that this game has that constant sum flavor of bargaining, right? So no matter what X is, X plus 1 minus X is 1. If I'm getting more of the goodie, then you're getting less of the goodie. And if you're getting more of the goodie, then I'm getting less of the goodie. There's no win-win here. There's no win-win. X and 1 minus X, there's no win-win. Now the idea is that after observing the offer, player 2 gets to make a choice. And theirs will be very simple. They can either accept the deal or reject it. They see the X and they can either say, you know what, screw you, I'm leaving. Or they can say, that sounds like a pretty good deal. So they can accept or they can reject. If they accept, then we'll have the deal as specified by player 1. Player 1 gets to keep X, they get X happiness points, and player 2 gets 1 minus X happiness points. X and 1 minus X. Notice that what happens at this terminal node depends on what was chosen by player 1. In other words, this one terminal node is actually just one representative of an infinite set of terminal nodes. There's a terminal node when X equals 0 and that offer is accepted. There's a terminal node when x equals 1 and that offer is accepted. There's a terminal node when x equals 1/2, 1/3, 1/4, 2/3, 3/4. Take your birthday and put it into 8-digit format, 2 for the month, 2 for the day, 4 for the year, and do that plus 1 over that over 1 plus that. That's between 0 and 1. There's a terminal node for your birthday. There's an infinite number of terminal nodes. And so when I write x1 minus x for this one representative x of what player 1 chose, this is just my way of saying that there's an awful lot of nuance going on there. But this is endogenously determined. Who is happy and who is sad depends on what offer player 1 chose to make. And we'll say that if the offer is rejected, then we'll just say that there's a disagreement point where we call that D1 and D2. D1 and D2. And in order to say that this is inefficient, we'll say that D1 plus D2 is strictly less than 1. Notice that if we manage to make a deal, x plus 1 minus x is 1. And if we fail to make a deal, D1 plus D2 is strictly less than 1. In other words, this is going to be efficient and this is going to be inefficient. Efficient, inefficient. Accept the deal, reject the deal. We made some kind of exchange, we have to have some conflict. So this ultimatum game is indeed a bargaining game. Let me just show you that by putting us into a utility imputation space. So what we're going to do is we're going to have player 1's utilities here and player 2's utilities here. You're so tired of this by now. That just means that you're getting more comfortable with it. So what I want to do first is I want to plot out all of the possible peaceful utility imputations. Notice that if x equals 0, then that means that player 1 has 0 happiness points and player 2 has 1 happiness point, which is exactly this point, 0, 1. Notice also that if x equals 1, then we wind up with player 1 gets 1 happiness point and player 2 gets 0, which is right here at 1, 0. And we wind up with a flat line. We're dealing with risk-neutral players, so we wind up with a flat line. Any intermediate x gets us somewhere along this frontier. Notice it's a Pareto frontier, right? It's a Pareto frontier because for every point, there's nothing up, there's nothing right. So for every one of these points, it's true that x plus 1 minus x equals 1. Every one of these sort of adds to 1. And then we'll just inject the disagreement point into the space. Here's D1 and D2. And because D1 plus D2 is strictly less than 1, this disagreement point lives south of the frontier. It lives south of the frontier. This is a bargaining problem so long as D1 plus D2 is strictly less than 1. If we wind up with a worse deal than we had if we made a deal, but we have conflicting preferences over the deals, x and 1 minus x, what could be more bargaining than what we just discussed? The ultimatum game is a canonical bargaining model. Not the only one. There are many variants. You can extend it. But this is the first thing where I tell you a story that involves some time. There's an offer, there's accepting, there's rejecting. This seems like something that happens. And we see that it is indeed a pure bargaining problem like we talked about in week 5. So the stories take us to the bargaining or the bargaining takes us to the stories. But no matter what, we see that we can't really get around this. There's a lot of political processes and economic ones where bargaining is a big part of it. And what that means is we want to make a deal, but we don't quite agree. How would we micro-found a political process around that? An institution around that? The ultimatum game is the simplest possible one. Let me just tell you a slightly richer substantive story to help you to see that. So I'm going to introduce the basic version of what's called the pivotal politics model. So in the pivotal politics model, we live in a one-dimensional policy space again, right? So here's very leftist policies and here's very rightist policies. It's the entire real line. So it's the entire real line, okay? Just like before, this is the space we've been living in. And the idea is that somewhere in this policy space, there exists a status quo. There's some status quo policy. And for now, I'm just gonna say the status quo is very far to the left. Okay, so we'll say Q is some status quo policy that lives over here, very far to the left in our policy space, or relatively far to the left anyway, right? Notice there's all sorts of stuff over here. But relative to the stuff that's going to matter, it's pretty far to the left. And I'm going to say that we have two players. We'll say that there's a pivotal voter, call them V, and we'll say that there's a proposer, call them P. So we've got two players, a proposer P and a voter V. where the voter V is pivotal. Maybe they're the median voter, maybe they're the filibuster pivot, maybe they're unanimity voter, whoever it is, there's a pivotal voter, and there's a proposer that's thinking about making a proposal to that pivotal voter. Just to get the story animated, I mean, there's all sorts of different combinations. We'll talk about those as we proceed in the class. We'll just say that the voter is pretty moderate and that the proposer is pretty far to the right. Okay, so the proposer is far to the right, the voter is pretty moderate, and the status quo is pretty far to the left. And we'll say that the proposer and the voter have absolute value utilities like before. They like to be close to their ideal point, and they don't like to be far from their ideal point. And so the story goes as follows. So at the beginning of time, we'll say that the proposer gets to choose some proposal. We'll call it X. So they choose some X in this policy space. They can choose any X that they wanted to. They choose some X. They choose any X that lives between negative infinity and positive infinity. Any real X. As far left as you want to go, as far right as you want to go. And the voter observes that and then decides whether to vote yay or nay. They say, I accept this proposal, and that will be implemented. Or they say, I reject this proposal. Your proposal sucks. And the idea is that if the proposal is accepted, then it's the new policy. And if the proposal is rejected, we remain at the status quo. And I'm telling you, that's an ultimatum game. Let me show you. So we'll say the proposer is player 1 and the voter is player 2. And at the beginning of time, the proposer chooses some X that lives between negative infinity and infinity. That's a bigger Assassin's Creed hoodie in a conceptual sense, but it's really just the same Assassin's Creed hoodie. It's just that you're not allowed to get yourself all the way to one side or the other. You can't get all the way to infinity, so you can't live on the extreme, you can't live on the edge of the hoodie, but you can choose anything between negative infinity and infinity. Negative infinity, infinity. You choose some proposal X. After that, the voter observes X and then decides whether to vote yay or vote nay. They can vote yay or they can vote nay. If they vote yay, then we'll see the utilities realized for the proposal. So in other words, the proposer's utility would be the negative absolute value of X hat of the proposers minus X, the chosen X. How far is the chosen X from the proposer's ideal point? And the same for the voter. The voter's utility will be the negative absolute value of X hat sub V minus X. How far is the voter's ideal point from the proposed policy and now accepted policy? And it's negative because they get sadder as we get further. Their favorite place is their ideal point, which gives them utility 0. And as we get further and further away from their ideal point, they get more and more negative utility, more disutility or whatever that means. And the idea is that if the proposal is rejected, if the voter votes nay, then it's the same utilities except it's the status quo policy instead of at the proposed policy. So the same utilities except plug in a Q. Negative absolute value of X hat P minus Q. Negative absolute value of X hat V minus Q. Same thing. Same thing. They're spatially motivated here, they're spatially motivated here. The question is, can I make the right choice? Can I choose the right policy that the voter will want it and I'm happier with it than I would have been before? Now let's think about how we drew this in the policy space and then consider a utility imputation space. I just want you to observe in this policy space that there exist opportunities for win-win, right? Because the status quo is very far to the left, and then there's the voter and then there's the proposer, then exist opportunities for win-win. The utility that the voter experiences and the proposer experiences for this extreme left policy of Q, they could both do better. If I moved to the voter's ideal point, I would make them both happier. I would make the voter as happy as possible, and I would make the proposer a little bit happier too. So in other words, I can draw a utility imputation space where the proposer is here and the voter is here, and I can locate the utility that they get for the status quo, which is going to serve the role of the disagreement point. That's the disagreement point. The disagreement point is what happens if you have to live with this crappy status quo. And then we'll say that within the realm of win-win, the voter wants to be close to the voter's ideal point and the proposer wants to be close to the proposer's ideal point. And the question of the pivotal politics model as we have it written down, the simple incarnation of it to get started is, what's the final policy going to be? Is it going to be the status quo? Is it going to be the median's ideal point? Is it going to be the proposer's ideal point? Somewhere in between? Why? Are we going to see a lot of yeses in Congress? Or are we going to see a lot of no's in Congress? What's the bargaining process look like? Because I'm not sure if you noticed, but this is a bargaining problem. So the pivotal politics model is a form of the ultimatum game, and the ultimatum game is a canonical bargaining protocol attached to a bargaining problem. So this is all just bargaining when we take time into account. I make an offer and then you accept or reject. And next week in the future, we'll see that there's a particular kind of result that emerges here where we see that whether you move first or second confers benefits or disadvantages. So you have that to look forward to. But in the meantime, in the C block, I want to talk about what the rule of law is all about. Oh, that's an overpromise if I've ever made one. You'll see what I mean when we get there, which will be now. So here in the C block, I want to introduce a simple model of the rule of law. So this is a nice model in its own right, but I've chosen to introduce it to you because it's also a good way to introduce an important conceptual idea. We've had two worlds. We've had the world where everything is simultaneous and nobody gets to observe anything. Strategic form games like we saw in weeks 6, 7, and 8. And now in the last two blocks, we've seen games where there's a time horizon, and if you're late, you get to observe everything perfectly that happened behind you. And the thing is, that might not be true, but the things that happen as if simultaneous might be embedded within the time structure itself. So I want enough flexibility to say that some of the moves are simultaneous, but not all of them. Because if it was all of them, I wouldn't need flexibility. I'd just write down a strategic form game. I'd just write down a matrix. So the question becomes, how do I write down a game that's intermediate in the sense that not everything is observable, but nothing is observable? How do we make some of the things observable? And it turns out that this rule of law game is a really nice way to see that. So the idea here is that there's three players, a ruler and two factions in society. I'll call them R for the ruler and A and B for the two factions in society. And the basic idea, the story is, once upon a time there was a ruler that was thinking about whether or not to take stuff off of the people. Right? So they're thinking, I can either repress the people and get some goodies off of them, or not repress them and be stuck with the status quo. But then the ruler's thinking, well, no matter what I do, if the two factions in society, if faction A and faction B manage to coordinate on throwing me out, then I'm in trouble. I'm dead. And it might be the case that they get more irritated. They might be more likely to try to take up arms against me. They might try to coordinate against me if I repress them. So I want to take the goodies, but I'm worried about their future potential for coordination. We'll model strategic time from left to right, like we had been before. And we'll say that at the beginning of time, the ruler makes a decision. So R controls the first node, and they can either not repress the people or they can repress the people. They can do something not nasty or they can do something nasty. They can not take or they can take. And the idea is no matter what happens after the ruler has decided to not repress or depress, faction A gets to make a move. So now there's two versions of faction A. Faction A has the choice they have to make if repressed and a choice they have to make if not repressed. So now there's two completely distinct versions of faction A depending on what the context set by the ruler is. That's what's happening. And then faction A can do one of two things. Faction A can either challenge the leader or they can acquiesce. So no matter what, they can either challenge or they can acquiesce. And then no matter what faction A does, faction B can either challenge or acquiesce. So now we've got like 8 outcomes. We went from one single repress and not repress decision. Like there's repress, challenge, outcome. Repress, challenge, acquiesce, outcome. Repress, acquiesce, challenge, outcome. Repress, acquiesce, outcome. And then the same for the bottom 4, right? But now there's like all these different ways to get where you're going. Now there's 8 different paths. There's 8 different histories. There's 8 different sequences of decisions that take us from the beginning of time to one of the Plinko outcomes at the end of time. And the idea is that what these outcomes represent depend on the decision to repress and the decision to challenge or acquiesce. I'm going to fill in the preferences first, and then I'll introduce the extra technology that we use to talk about what can be observed and what can't. So the basic idea is that it takes both factions in society to throw the ruler out. And if you try to throw the ruler out without the other faction helping you, Now you're in a lot of trouble. Like you lose happiness for that. The ruler doesn't want to be thrown out. They don't want to wind up in a situation where both challenges happen. They want at least one acquiescence. In broad brushstrokes, we'll say that the ruler gets 8 happiness points if they repress and stay in office. They get 2 happiness points if they don't repress and they stay in office. And they get 0 happiness points if they're thrown out of office, right? So if they repress and then there's challenge, then that's 0 happiness points for the ruler. Otherwise, it's 8, right? Because in the other 3 outcomes that happen after repression, in the other 3 outcomes, then they don't get thrown out. One of the factions went after them, but not both. And I said it takes both to throw the bastard out. So there's 0 happiness points up here for the ruler, and then 8 for the others. And then that pattern is going to be similar down here in the bottom half where they didn't repress. If they don't repress, and then there's a challenge, 0 happiness points for being thrown out of office, even though you were nice. And if you stay in office without having repressed, that's 2 happiness points. So 2, 2, 2. So 0, 8, 8, 8. 0, 2, 2, 2. And the basic logic is going to be flipped. If the people keep their stuff, they get 8. If they don't keep their stuff, they get 2. And the idea is that challenging causes a happiness point too. So going out into the streets and protesting, somebody's going to die, somebody's going to get hurt, somebody's going to get arrested. It's a costly thing to do. And so protesting, trying to throw the bastard out through challenging the bastard takes a happiness point away from you. So if we see repress and then challenge, the bastard gets thrown out. That's the 0 happiness points for the ruler. And we'll say 7 happiness points apiece for the 2 factions. If it goes repress, challenge, acquiesce, then that'll be 8 because the ruler's in office, 2 for the acquiescer, and 1 for the challenger. And then if they both acquiesce, it'll be 8, 2, 2. And then down here in the world where there wasn't any transgression, where the ruler was nice, well, if they throw the bastard out anyway, then they still have to pay that cost of going out into the streets and doing some protesting. So 0 happiness points for the ruler who got thrown out of office, even though they tried to be nice. And 7 happiness points apiece for the factions. And the idea is that if they haven't been repressed, the people have 8 happiness points to play with instead of 2. So if it goes don't repress, acquiesce, then that's 2, 8, 8. And if one acquiesces and the other challenges, then the acquiescer gets 8 and the challenger gets 7. So we've filled in all 8 terminal nodes with utilities for all 3 players. So the game as we've written it has the feature that the ruler moves, and then faction A observes what the ruler does perfectly, and then faction B observes what both the ruler and faction A did perfectly. Faction B gets to observe everything that happened in the past. Faction A gets to observe everything that happened in the past, and the ruler doesn't have a past. And so suppose that I wanted to encode the idea that not every situation is one where the factions in society can meaningfully coordinate that way. Where like faction A goes out into the streets and says, we're protesting, come on and join us. That doesn't happen all that often. What if we live on different sides of the country? What if there's a desert between our 2 strongholds? What if we're not in the same ethnic group? What if we don't speak the same language? Maybe we're not able to coordinate. Maybe it's not like faction A goes out into the streets and faction B goes, oh, I see them and now I'm going to go. What if faction B doesn't really get to see what faction A did? They can see what the ruler did, but they can't see what faction A did. In order to encode that, I want to introduce the notion of an information set. What an information set is a way of linking decision nodes for one player as a way of saying they don't know which of these decision nodes that they're at. Let me show you what I mean. So let's just begin from the world where the ruler transgresses. So at this moment, faction A can acquiesce or challenge, and then as we've written it, faction B can either acquiesce or challenge either way, having observed what happens. The thing is, if faction B didn't get to observe faction A's choice because of the reasons I just discussed, then they don't really know which of these 2 decision nodes that they're at. They don't know which they're at. They don't know if faction A challenged or if faction A acquiesced. And so consequently, I'm going to link these with this little rectangle or whatever I'll put in there. And that means faction B doesn't know which of these 2 nodes they're at. When they make one and only one choice from this information set, they don't really have 2 decision nodes. There are 2 paths to outcomes, but they don't know which they're at. At any given decision node, they make one and only one choice. Notice that means that for every node covered by the information set, there has to be the same available choices. Because otherwise you'd like, if it was like, if they challenge you can go left or right, and if they acquiesce you can go up or down, and then you woke up one day and somebody says, well, you can go up or down, what do you choose? You're like, well, now I know what Faction A did. So this information set is my way of saying Faction B knows that we're in the world where repression happened, but they don't quite know what Faction A did. I can do the same and will do the same for Faction B's informational issue in the world where there wasn't transgression. So if I go down to the bottom half of the tree, I can put an information set rectangle around Faction B's 2 decision nodes there. And that's my way of saying that Faction B gets to observe if non-transgression happens, but they don't get to observe what Faction A did. You can imagine saying something like, well, you get to observe if there wasn't transgression, and if you do, and you do get to observe if there is transgression, or something like that, which would just mean that one half of the tree has an information set and the other one doesn't. I just wanted you to get the idea that we can have Faction A observe what the ruler did, we can have Faction B observe what the ruler did, but we can have Faction A and B have this issue that they can't quite coordinate, just like in simultaneous move games from before. This information set thing we'll see basically turns into simultaneous move games with matrices. We'll be discussing that next week when we start to analyze games like this. But even before the analysis kicks in, I hope that there's some intrigue in here, because look, basically an elite is setting some level about how many goodies there are in the world for the people. And the people have a chance to react to the policy set in place by that ruler. The issue is those people don't have the same time informational advantages. They can't observe one another as well as they would like to be able to get to exactly the outcome they would like to if they could have coordinated. So even though they get to see the bastard make the bastard's moves, they don't know how to react to the bastard together necessarily. So time is something that we can exploit all the way so that everybody can observe everything. Time is something that we can exploit none of the way so that we're back at simultaneous move games. And if we're clever with information sets, we can get those intermediate levels where some things are observable and others aren't. All this just from some dots and some lines and some rectangles and some numbers on some of those dots. This story is getting richer and richer and richer as we go, but you're getting faster and faster too. You're getting nimbler and nimbler. And even though this is a completely different style of analysis, in a sense, my hunch is that you followed me pretty well, even though I've done my usual shitty job. So this is the rule of law. The rule of law depends on expectations of the future. This is part of what institutions do. So if we think about pivotal politics, or we think about candidate entry, or we think about the rule of law, in all of them we see the institution of some process, the way that we repress, the way that we run for office, the way that we haggle in legislatures. We see that those are encodable if we're smart about time. And over the next few weeks, I'll show you a few more interesting things about how to tell stories this way. But just as importantly, next week, we'll talk about how to analyze them in a way to find outcomes that respect time rather than those that don't. So what do we talk about today? Now, look, this was a big innovation in the sense that we can now explicitly incorporate time, strategic time, into our fables. But it's worth acknowledging the fact that the fables we had before didn't necessarily imply real synchronous decisions. When the two suspects are put into the two separate interrogation chambers, the separateness of the interrogation chambers means that they move as if simultaneously. Even though I probably would tattle on you immediately because I'm a very efficient jerk, and maybe you would have to hold out and wait for the good cop, bad cop or something. Regardless, we might not make our decision at the same time, but we don't get to observe, and that's the defining feature in strategic time. So if I don't get to observe what you did, or I can't even imagine what it would look like if I could, then I'm simultaneous. And if I'm not, then I'm sequential, and I'm in the world of extensive form games, the world that we're in now after our new innovation. Extensive form games, they're much more popular in political science than simultaneous move games. You see a lot more trees in political science journals than you do matrices. Now, part of that is that the matrices are a little bit older than the trees were. The trees were a little bit of an innovation that happened a couple of years in the development of game theory. So it could just be that the old stuff got covered first and the newer stuff is what we cover now. But I think that it's more than just that. I think that one reason that you see so many more extensive form games than simultaneous move games in the political science literature is the political scientists very naturally think about strategic time. We think about how institutions give procedural power to people that move early or late. We think about the decision to fight a war, and I might move up to the border and then you make a decision about whether or not to call my bluff. You see something I did and then you react. You see something I did and then you react. That is a core strategic decision that emerges either under political institutions, depending on who has procedural power, who's the proposer, who's the voter, who moves first, how does a bill become a law, all of the steps. This is all stuff the political scientists love. What do we love more than the how does a bill become a law poster? Or it can happen under complete anarchy, where I'm making a decision about where to put my army and you're seeing where I put my army and then deciding whether or not to take umbrage and fight me. So whether the time emerges for imposed reasons like under an institution or for organic reasons like under anarchy, no matter the case, strategic time is all around us in the world of politics. Observe and then choose. Observe and then choose. Potentially update your beliefs about things and then choose. But no matter what, take into account what you expect in the future. So you might be thinking that this is like the most silver bullet ever because it looks a little bit easier, it's a little bit more intuitive, you don't have to do stupid hypotheticals, and apparently it's something that political scientists would want to talk about. So that sounds like the quadfecta or whatever we're going to call it. And in general, that's right. Extensive form games give us a nice way to talk about time, they simplify the analysis, a lot of good things happen. But there are costs to this approach as well. They're somewhat esoteric, they're somewhat abstract, they're somewhat vague, and therefore they're the sort of things that give me a headache at night. And it's with that headache fresh in my mind that I'd like to conclude with a provocative thought. Time is an important part of accounts of causation as well. If I'm trying to tell a causal story, something happens, some choice is made, and then, after, some effect happens or doesn't happen. So I take an aspirin, and then I experience a reduced headache duration. You go to college, and then you enjoy higher wages. A bunch of people post on Twitter that they're going to go protest against the government, and then censorship happens. The cause precedes the effect. The cause and then the effect. This motivates the counterfactualist style of analyzing causation, where the idea is if I want to make some claim that some cause C causes some effect E, then the way that I show that is to show that if C had not been true, if I hadn't had the cause, then I wouldn't have seen the effect. And the way that I think through whether that is indeed causal is I say to myself, well, if the cause hadn't been there, what would have happened? So I take an aspirin and I see a headache of a given length. But in order for me to say that the aspirin caused a shorter headache, I have to think through how long my headache would have lasted had I not taken the aspirin. Counterfactualism is the main way that we think about causation. This is from philosophy. This goes back, well, there's a long tradition of counterfactualist causation, but it actually didn't get encoded until the 20th century. And even then it was like the 1970s, even though the idea goes back at least 500 years. Encoding things right is hard. So there's this notion that you have to have the cause precede. But here's a question for you. And this is a weird question that's going to involve a lot of hair splitting, per usual. So if you have a headache, what causes you to take the aspirin? So we just said that the aspirin might cause a shorter headache, but what causes you to take the aspirin? What causes you to make a choice? What caused you to go to college? We can say that going to college has a causal effect on your wages, but what caused you to go to college? What, if it weren't true, is the thing that would have made you not go to college? If I'm thinking counterfactualistly, and I'm thinking, I see you went to college, what is the thing that if it wasn't true, you wouldn't have gone to college? And importantly, does it precede your decision to go to college? What is the thing that if it hadn't happened, you wouldn't have taken the aspirin? And does that thing precede your decision to take the aspirin? What are the causes of strategic choices, and do they happen prior to those choices? Now, in a sense, yes, right? So you chose to go to college, and one of the things that caused that might have been somebody came to your school in high school and said, come to our college. Or maybe you had a guidance counselor or teacher that said you should go to college. Or maybe you had a family member or a friend that said you should go to college. Or maybe societal pressures at large said you ought to go to college. Or maybe you decided to sit down and did the research and you crunched the numbers and you found out that if you go to college, then you can expect to get a higher wage. Or maybe you found out that there was some crazy fat man that will shout at you for an hour and a half every week if you let him. Well, no matter what it is, you decided to go to college, and I want to know what caused that. Now, here's an interesting thing. If you're anything like me, part of what caused you to go to college is what you expected to happen to you in the future. If you choose to take an aspirin, you're not doing it because of what happened in the past. If you take an aspirin, you're doing it because of your expectations that it will reduce the duration of your headache. If you go to college, you do it in part based on what happened in the past, but also on your expectations of the future. You have to make risky choices in life and you have to be able to sleep. And it would be nice if you knew what the causes of that were. Right? And how would you think through the structure of such a cause? How would you know a cause of a strategic choice when you saw one? We'll be talking about that next week. We'll be talking about what causation looks like in the context of an extensive form game, but that's not really a true causal model. That's not a philosophical model. That's just a way to approach counterfactualism when we have a particular apparatus to play with, the apparatus being a tree. But it isn't obvious to me. It's not obvious to me what the causes of strategic choices are. I don't know what causes them. I don't know what, if it wasn't there, we would make different choices. Is it information? Is it previous history? Is it expectations of the future? In other words, does it have something to do with the past or with the future? Do causes precede or do they come after? Or is there something in my brain that takes what I expect about the future based on what I learned from the past and then makes it my present decision? How do you change somebody's expectations? How do you change somebody's expectations of the future? How would I change your expectations of the future? I'd need to change the data available to you. Or I'd need to show you a new method of taking what data you have and turn them into predictions. Either way, I have to give you either new information or new methods for using information. I have to alter how you take the past and turn it into the future. Strategic time up all this causal stuff. So the provocative thought isn't any of this, because this is just mostly just me sounding stupid, and you're like, we noticed. My provocative question is the following. Can any strategic choice be caused the same way that heating the temperature causes ice to melt? Are the causes of a particular legislative proposal the same thing as the causes of rain? Is there something more deterministic in things that don't involve strategic choice, and therefore are the causal mechanisms easier to trace? Or is it just that we don't get to use the word cause about our choices? Does volition stop us from being good counterfactualists? Does volition stop us from thinking only about the past, about what gets to be a cause? Does the fact that we can take data and turn them into expectations, does that make us different than everything else out there? Can we be caused to do things the same way that ice can be caused to melt? I don't know. I don't know. Don't look at me. I don't know. It was just a stupid question I had. But it's one of those things that I don't even think that it's a telling question. There are some questions that are unanswerable, but that your guesses are telling. Is the glass half full or half empty? That's telling. But this isn't telling. This is just a mind right? I think that they're both good, though. I think it's good to sort of twist yourself in the pretzels whenever you get a chance, because you might not be able to untwist yourself all the way, and that's when the good stuff happens. So every time we introduce a big innovation, there's a chance to say, boy, this is a fun thing to do. Boy, I can see all sorts of new possibilities. But there's also reason for humility, because we might not be able to understand every single thing that comes out of our new innovation. Our new innovation might be very helpful in the present, most immediate concern, but it might also throw off things that are truly foundational. We might not want to swim in those big, deep waters because we don't really know what all is out there. But then again, would you want there to be deep water out there that you chose not to swim into? And what would have caused you to feel that way about it? I'm not going to do better than that, because this is about as glib as I can look at the end of a talk. So let me just add that I'm looking forward to watching you go through some extensive form games, some time-respecting fables, thinking about the role of strategic time in your life and in the lives of political actors. So I'll see you in the future, whenever that happens to be relative to when I recorded this. Isn't time weird? I expect to see you in the future, although I have no idea what causes you to come to class. Regardless though, thanks for watching.